Hello guys, I'm a teacher M.Nelkon Masame. Let us take a look on the question below from A.F. Abbott. It is just the Archimedes principle and the law of flotations. We have given a cube that has got a size of 15 centimeter, and this tube is floating in water in such a way that its depth is 10.5 centimeter with its sides vertical. Remember the word with its side vertical. From this with its side vertical is where we get confusing how we can draw the diagram representation for this without taking consideration with its side vertical. You may draw the diagram consideration as you can see below. You can take 10.5 centimeters from the surface of the water to the surface of the top of the tube, and the total height it is 10.5 centimeter and 15 centimeter. This is very wrong way of understanding the concept that the depth is below the surface and with its sides vertical. The sides is 15 centimeter, the depth is 10.5 centimeter, and as the sides and the depths are in the same vertical, all are in the same vertical line or sides. Okay, we may use these diagrams to indicate the forces that act on this cube while it is at a certain depth from the surface of water. And as we are saying, this is top and this is bottom of the cube, and this height is height of the depth of the cube at the top, from the top to the surface of water. This is also from HB. This is depth from the point O to the bottom of the cube. That's why we are saying H sub B. And the force that acts on the top of the cube is directed downward. That's we call it a force F sub T, the force of the acting on the tube at the top of the tube. And the force that acts upwards as a result of this depth HB is directed upward as force that acts at the bottom of the tube, that's F sub B. And the upthrust is acting upward as usual. Okay, as I define here is what I try to explain at one point, and then let us consider the vertical forces and try to resolve these vertical forces so that we can see what will result. Okay, from a sum of vertical forces is equal to net force at a vertical directions, then FB is going up, it's positive, R plus is going up, it is positive, but F that is acting at the top is going down, that is negative. Our net force is equal to 0 because there's no net vertical accelerations. Now our result expressions is, as you can see here, the force at the top minus the force at the bottom of the cube. But forces generally is defined as a pressure times a area of the cube. That is, area of the cube is L times L, that is the square length. And now the pressure we are saying as a pressure at the top, pressure at the bottom, that is pressing at the bottom, this cube at the bottom, and this is pressure that pressing this cube at the top. And now when we define pressure also, that due to water will be equal to density depth times G. Remember, this is depth for top, depth for bottom. Then at the end we get to this general formula for finding upthrust. Okay, and these depths are always negatives as observed from point O. This depth, all of this depth at the top and depth of the bottom is negative, or since they are called depths, hence they must begin from 0, or from the surface of the water to the certain deep of that vessel or of the water body. Okay, hence all of this depth we assign it a negative sign. Then when we put it a negative sign, then it will become depth of the bottom minus depth of the top, and this is our very general formula. Okay, now we substitute the values and we get R plus T as 23.625 Newton. As you can see here, the expressions that justify these expressions. From the law of flotations, we know that R plus T of the cube is equal to weight of the cube that floats. Our R plus T is equal to weight of the cube. Now we define our weight of the cube, density of the cube or arc, times the volume of the cube, times G is equal to R plus T. Remember that this volume of the cube is the volume that is when the cube is inside, is the same as the volume when the cube, the total volume of the cube, which is equal to L a power 3, that is L times L times L. Now when we substitute and we make the selected density of the cube, we get the result as you can see here. We just refer the expression for R plus T and we substitute this expression for R plus T, and we get our general formula as this one when the HH is there, and this one when the H at the top is equal to 0, because at the top it is air that is present at the top here. That here is got a depth of 4.5 centimeter from the top to the surface of the water. Hence there is no water at this depth. Hence for a water depth here is equal to 0. That's why we said here HT for water is equal to 0, but for air from the top of the cube is equal to 4.5 meter. Don't confuse this, because the fluid present above the surface of water is air, and this is not water at all. Hence we have only depth at the bottoms, and our final answer is equal to 700 kilogram per meter cubic, or 0.7 gram per centimeter cube. Thank you for watching. Please share, like, comment. Don't forget to subscribe for more videos like this one. Thank you.